Okay, this is hopefully a familiar graph to a lot of you. We've got the graph from the photoelectric effect. Okay, we're looking at two different surfaces, L and H, and we know the minimum photon energy required from surface H is less than from surface L. We want to know which graph shows the variation of the energy with the frequency. Over to you, you try the question, and when you're ready to see an answer, press play. Okay, so as I've said before, this is a familiar one, and hopefully you've seen this kind of question before. It worked well with a lot of the other questions on photoelectric effect. It's interesting again, because there's a good attempt here to probe your understanding of certain key terms, and that key term here really is this minimum photon energy. We'll come on to that just now. Let's do the usual thing. If we see this graph, what we want to do is remember that we're dealing with HF equal to phi plus E max. Let's go through these terms. HF, that's the energy carried by a photon. Phi is the work function. That's our minimum photon energy required to emit electrons. And we've got the E max, that's the maximum kinetic energy. Now, what we're going to do is we're going to do our usual thing. We've done this a few times in the videos, rearrange this to get this into a form y equal mx plus c. So we've got energy max on the y-axis, F on the x-axis, H in front, and then a minus phi here. Why is that important? Well, if we compare it to y equals mx plus c, you can see hopefully that we've got a couple of things going on here. Firstly, that c is equal to minus phi, okay? And as we know that the work function, the minimum photon energy of H, is less than from surface L, that tells us some information about what we should be looking for. Put simply, we're going to expect the graph that we're looking for to cut the y-axis at a, let's get this right, greater value. Okay, that's so we've got a negative y-axis, we've got a negative y-intercept. We know that for H it has a lower value of the work function, so we're expecting it to cut it at a lower negative value on the y-axis. Now you notice all these graphs cut the y-axis at a lower negative value. Okay, the correct answer here is going to be D, because we're expecting it to cut at a lower value, but we're also expecting it to have the same gradient. Okay, the gradient here is equal to H. So regardless of the surface, they should have the same gradient, which is why A and B are out. However, they should cut at a less negative value, so that you could say that the y-intercept is less for H than L, because it has a lower work function. I think the confusion here could come from that minus sign. All we need to remember is that our y-intercept gives minus the work function, and then hopefully that makes sense.